All right, guys, here are all the problems from chapter 4 and chapter 5. These should be pretty familiar because they're the most recent things we've done. This first one says graph the function shown by each table. Tell whether the function is linear or non-linear. So you do need to choose what you're going to count by. On this first one, on the bottom, I'm going to count by ones. And then vertically, if we have to get to 20, I'd probably count by twos. So just keep in mind, you got to be consistent with whatever it is you're going to count by. And then you just plot those points. So 1, 0 is here. 2, 1 would be here. 3, 8 is here. And 4, 20 is right here. So the question is that linear? And if you were to draw a line through it, you don't need to draw the line, but just so you can see, that's not a straight line, right? So we would say this is non-linear. Okay, feel free to pause and slow me down or speed me up and fast forward if you don't need all the details on this. Number 10, if you look here, again, I would count by ones on the bottom. And then vertically, I think I would probably, I'd probably count by twos, I guess. Yeah, I'd probably count by twos. You can count by 1.5 otherwise, but that's kind of a weird number to count by. So we'll go by twos again. So that's plenty high because we only have to get up to 13.5. And then just be careful when you plot these. 1, 0, right? That's right here. 2, 4.5 is not halfway between 4 and 6, right? It's a fourth of the way. 5 would be halfway between, so 4.5 is right about there. 3, 9, that one's halfway in between, right there. And then 4 and 13.5. 13.5 would be 3/4 of the way because 13 would be halfway. So then when you look at that, you can see this one actually does make a straight line. So this would be a linear function. All right, down to number 13. It says graph the function rule, explain why the graph is continuous or discrete. Your cost C to buy W pounds of walnuts at $6 per pound is represented by this function. So first of all, continuous or discrete. And if you think about that, basically what they're saying is, do you have to buy exactly 1 pound or 2 pounds or 3 pounds of walnuts? And a lot of places, like if you go to like Winco, for instance, you can just scoop however much of it you want and put it in a bag and then you weigh it. So it'll be 2.75 pounds, right? So that is the reason this would be continuous. You could buy a fraction of a pound. In other words, you don't have to buy full pounds. You could buy 2.5 pounds. You could buy 3.7 pounds. So that's continuous. You would draw a line through it. And then we graph it. So we have the weight is going to be our X value, right? That's the W. That kind of is replaced with an X. This is a Y. So this is the cost of it. So on bottom, you could count by ones. You can count by 1.5 or halves if you wanted, just to show the fractions of a pound. And then if it is $6 per pound, you could count by sixes, but that's going to make for a really short little graph. I would probably just count by twos, maybe. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So if it is, you know what? I guess I can get to 3 on this. It's up to you. I think on the answer key, I probably counted by sixes. You can count by sixes. You can count by threes. Threes wouldn't be a terrible number. You know what? I'm going to do that. I'm going to count by threes. If you did twos, you can do twos. You just won't get as many points in. If you count by threes, okay? Then to plot some of these, if I plug the cost equals 6 times 1, then my cost is 6, right? So 1, 6 would be a point on the graph. If you plug in a 2, 6 times 2 is 12, so 2, 12 would be a point on the graph. If you plug in a 3, you'd get 18, so 3, 18 would be a point on the graph. If you plug in a 4, 6 times 4 is 24. If you plug in a 5, you would get 30. So it looks like this. We said this would be continuous, so you can go ahead and draw that line in, and it'll look like that. All right, next one here is number 18, and this one says, write a function rule to represent each situation. So your total cost C for hiring a gardener is $200 for an initial consultation plus $45 for each hour that he spends drawing plans. So your cost is a flat $200 and then $45 per hour beyond that. So I did $45 times the number of hours plus that $200 initial fee. If you rearrange that, if you put the 200 first, that would be okay also. So you could do 200 plus 45H. That would be okay. All right. 21 says evaluate each function for x equals 2 and x equals 7. So remember, function notation says f of 2. All that means is when I plug 2 into my function, right? So this is going to be 2 times 2 minus 8. So 4 minus 8, which is a negative 4. So we would say f of 2 equals negative 4. Okay, when I plug 2 into the function, I get a negative 4. Then they want to know f of 7. So if I plug 7 into the function, f of 7, I get 2 times 7 minus 8. So 14 minus 8, or 6. So that would be f of 7 equals 6. Okay. 23, it says the domain is this, right? Those are your x values. What is the range? And the range is the y value. So t of x or y in this case, when you plug in each one of these x's. So we would say t of negative 3. So if I plug a negative 3 in, I would get the function negative 3.8 times negative 3 minus 4.2. Okay, and I'm not even going to plug that in yet. I'm just going to show you all the setup. Then t of negative 1 would be negative 3.8 times negative 1 minus 4.2. Remember, I showed you a way on your calculator to do this so you didn't have to keep typing everything in every time. Oh, sorry, that's not a negative 1. That's a negative 1.4. My bad. Here, let's erase a little here. T of negative 1.4. Sorry. So t of 0 is going to be negative 3.8 times 0 minus 4.2. T of 8 is going to be negative 3.8 times 8 minus 4.2. Okay, so you plug all that in straight across, right? Plug this into your calculator, you get 7.2. Okay, plug this into your calculator, negative 3.8 times a negative 1.4 minus 4.2, and you get 1.12. Plug this one in and you get negative 4.2, and then plug this one in and you get a negative 34.6. So when it asks you for the range, okay, domain and range both, you have to put in order from least to greatest, and then no repeats. So my smallest would be a negative 34.6, then negative 4.2, so just reverse of how we solved them, 1.12, and 7.2. And that will be the range of that function for that domain. All right. back up to the top here, recursive and explicit. Remember the recursive formula, I'm just going to write the basic version here, is a sub n, sorry, not n, a sub 1 equals something, and then a sub n equals a sub n minus 1 plus your common difference. Okay, so that's the just like general form for a recursive. The explicit, the general form is a of n equals a sub 1 plus n minus 1 times the common difference. Okay, so you have your recursive, you have your explicit. What I would do then is to write my recursive formula here. I would start with just that general form. A sub 1 equals and a sub n equals a sub n minus 1. That never changes, okay? A sub 1 is your first term, so that's the 3. A sub n, that's the term number. So a sub n equals the term before it, a sub n minus 1. And then you look at what's happening. So to get to the next one, we were adding 5 each time. So your common difference is a positive 5. So this is the recursive formula. And then the explicit formula is a of n equals the first term, 3, plus n minus 1 times your common difference, which is the 5. So that would be your explicit formula. And if you wanted to simplify that, you could simplify it, but you don't need to. You can just leave it right like that for me. Okay, so this next one, the recursive formula, you're going to say a sub 1 is 4, and then a sub n is a sub n minus 1, and then you're looking at what is happening from one to the next. And each one of these, you end up adding, or it can be subtracting, right? If you're subtracting something, it would be a negative number that you put behind here, or minus that number. This time we are adding again, so plus 2.5 each time. So plus 2.5, that is your recursive formula. And then your explicit formula is going to be a of n equals the first term plus n minus 1 times that common difference of 2.5. Okay, so that's your explicit. And again, you don't need to simplify that any further for me. You could, if you wanted to make the equation a little simpler, that's fine, but I'm not going to make you do that. You can just leave it right like that. All right, so that, I believe, is all the chapter 4 stuff. Now here's the chapter 5 stuff. This should be very familiar because you just did this stuff and you did pretty well with it. So this says find the slope of the line that passes through each pair of points. Remember, your slope formula is y2 minus y1 over x2 minus x1. So we're going to go x1, y1, and x2, y2, and plug that into slope formula. So it's going to be 1 minus 2. Okay, so that's 1 minus 2 over, and then 3 minus 2. So 1 minus 2 is a negative 1, 3 minus 2 is 1, so you get a slope of negative 1, okay? And then it says find the slope of the line that passes through each pair of points. That's all you have to do on this one. All they wanted was the slope, so you don't have to plug that back in. You don't have to create an equation from it, just find the slope. All right, this one, x1, y1, and x2, y2. So we're going to go y2 minus y1, and then x2 minus x1. So that's minus a negative, which is actually plus a positive. 5 minus 2 is 3, 0 plus 1 is 1, and that can actually just simplify to a whole number 3 for your slope. Number 10, find the slope. Remember, you start at the point that's farthest left. So if these are our 2 points, we're going to start at this one, and then you do rise over run. So 1, 2, 3 up, 1 over. So your slope is 3 over 1 again, which is 3. Okay, the slope of that line is 3. And then this next one, you have 2 points again. Start at the one on the left, and you have to go down and to the right. So down is a -1, to the right is 2. So your slope here is a -1/2. All right, now this one kind of takes the finding of a slope and then putting it into an equation with it. So first thing it says is write an equation in slope-intercept form that passes through the given point. Excuse me. So this is x1, y1, x2, y2. This one's a little bit goofy. I wish I would have picked different numbers. I didn't pay attention to what I was doing here when I picked this number, I guess. But it's fine because the process will still be there. It's just going to look a little different in the end than they typically do. Y2 minus y1. So 4 minus 4. 1 minus a -3. So you get 0 over 4, which is 0. That means our slope is 0. Now that should tell you something, because when the slope is 0, it is a horizontal line, right? Remember our OI Vux, when the slope is 0, it's horizontal. So that's fine. If you remember that that's a horizontal line and that horizontal lines are y equals, that's helpful because you already have your y value. But if you don't remember that, that's okay, because what you can do is still just take a point, I'm going to use the second one here, and plug it into slope-intercept form. So slope-intercept is y equals mx plus b. So if I plug in this as my x and my y, 1 and 4. So 4 equals the slope of 0 times the x value of 1 plus b. This is 0. So it's 4 equals your b value. So if I put this and the slope into slope-intercept form, y equals 0x plus 4. What's 0x? It's 0, right? So really this goes away and you just get y equals 4. So that's why that one's a little goofy. If this was a 1/2, then it would have been y equals 1/2 x plus 4, and you would have been done. But it's the same process. Okay, then it says graph each equation. So this is slope-intercept form. Slope-intercept form, you are going to go down 3, 1, 2, 3, and then a slope of 4. So up 4 over 1. And that's going to be your point. And then I would do it again. 1, 2, 3, 4 up over 1 will get you this line. Okay. Second one, y equals 2. That's a horizontal line at 2. So y equals 2 is this line right here. 24, this is in point slope form. Okay. In point slope form, you have a point and you have a slope. Your slope is the 2. Your point is an x value and a y value, but remember they're in opposite places and they are opposite amounts. So this is actually a positive one, even though it looks like a negative one. And this is a -3, even though it looks like a +3. So 1, -3 puts us here. And then with a slope of 2, we're going to go up 2 to the right 1. Up 2 to the right 1, up 2 to the right 1. So you get this line in point slope form. Now you could have turned it into slope-intercept and solved for y and done it in slope-intercept form also. Sometimes that's great, other times it's not as great. So up to you. This one you are doing from standard form. And remember, this was the cover-up method. So if we ignore this, my equation is x equals 10. If we ignore the x, then the equation is 4y equals 10. So this one is done. Your x-intercept is 10. This one, you would divide by 4, and y would equal 2 2/4, or 2.5. So here's what I would do. These are intercepts, okay? If my x-intercept is 10, I would count by 2's everywhere. So I'm going to go 2, 4, 6, 8, 10, 12. And then same thing here. 2, 4, 6, 8, 10, 12. So an x-intercept of 10 puts us right here. A y-intercept of 2.5 is going to be a quarter of the way up because it's not 3 would be the halfway mark, right? And then you just connect those 2 points. Your x-intercept and your y-intercept make a line, okay? Or the connection of them. Ooh, sorry. Okay, home stretch here. So this says write an equation of the line that passes through the given point and is parallel to the graph of the given equation. If it's going to be parallel to this equation, it needs the same slope. Okay, so my slope is going to be 5. And then we have a point. And now here's the thing. This is the one where I said you have options. If you want to start in point slope form, start in point slope form. If you want to start in slope intercept form, start in slope intercept. I'm going to show you both so you can choose the way that you like. So if I start in point slope form, I would go y minus my y value. So y minus a -1 is y plus 1 equals the slope times x minus my x value, which is 2. Okay, so if I put it into point slope form, it would look like that. If I wanted to do it in slope intercept form, then I'm going to use those same things, but in a different way, in y equals mx plus b. So I'm going to say y, -1, equals m, which is 5, times x, which is 2, plus b. So -1 equals 10 plus b, and then take away 10. So -11 would be your b value. And now you take the 5, the slope, and the y-intercept and plug it in. So y equals 5x minus 11, and that would be slope-intercept form. Okay, I know these look different, but if you turned the point slope form into slope intercept, they would be exactly the same. So just pay attention to which one you're supposed to be finding. In this one, I didn't specify, so you could do either one. All right, 28 says, are these parallel, perpendicular, or neither? And explain. So this is y equals 6x plus 2, which means your slope is a 6, your y-intercept is a 2. So we need to rearrange this one so we can get our slope, okay? So we're going to take away the 18x. So you get -3y equals -18x plus 15, and then divide by -3. So y equals 6x minus 5. So here's your two equations. Notice they have the same slope and different y-intercepts, so these would be parallel. And you can just say same slope, different y-intercept. Okay. Then 30 and 31 says, write the equation of the line that passes through the given point and is perpendicular. One of these I will do, I might do them both in slope intercept. I feel like more of you were doing slope intercept. I'll do the second one in point slope. The answer key did them both in slope intercept, but I will do them both here, one of each kind. So if you want to see it, slope intercept, that'll be 30. Point slope, I'll do 31. Okay. So perpendicular. Okay. If this is my equation, you got to think what is perpendicular to a slope of -3. So if your current slope is 3, sorry, my thing is dying on me here. Your current slope is 3, then the perpendicular slope is going to be the opposite reciprocal. So positive 1/3. And then you have your x and your y for slope intercept form. So y equals m times x plus b. So 5 equals 1/3 times 3 is 1 plus b. And then we just take away that 1. So your b value is 4. Your m, we want the perpendicular one. So this would be y equals 1/3 x plus 4. Okay. 31, same idea, but we're gonna do it in point slope form instead. So here's your slope, okay? That means the perpendicular slope is gonna be the opposite reciprocal of that. So right now it's positive, we're gonna make it negative. Right now it's essentially 8/1, we're gonna make it 1/8. And then this is gonna be our x1, y1 in point slope form. So what we're gonna do is y minus the y value equals the slope times x minus the x value, and then that would be your point slope form, okay? If you did slope intercept, it comes out to this. 10.5, or you could call it 21 halves, or you could call it 10.5, but typically we don't like decimals and fractions together. So this is slope intercept, this is point slope, and that is 4 and 5. Enjoy.